Hi, this is section 5.3, trigonometric functions of real numbers. So they start us off with the trig functions, there's 6 of them. And it says if t is a real number and p x of y, x comma y is a point on the unit circle. So they're introducing the unit circle to us. And I posted it on our module. And it looks like this. And this unit circle is going to come in very handy. It's got a lot of angles in standard position, both in radians and degrees, and it's got their corresponding coordinates on the unit circle. So notice that the the radius of the circle is 1, and that's why this is called the unit circle, because it's 1 unit. The radius is 1 unit. So when that is the case, when you have a point on the unit circle, then sine is just the y coordinate, cosine is the x coordinate, tangent is y over x, and of course we have the reciprocal functions. All right, so let's look at this first problem. It says let this point be on the unit circle. So right away, we know it's on the unit circle. They tell us that. And they want us to find the values of the trig functions. So we need to find the 6 values. So the first thing we should do is probably graph this. So we know it's in quadrant 2 because it's a negative positive. So that means negative positive, quadrant 2. So it says negative 15 over 17, then 8. So it's going to be somewhere over here. And we can put the point there. There we go. Negative 15 over 17, comma 8 over 17. All right. And now we need to find all the trig functions of that point. So that shouldn't be too hard since it's on the unit circle. That's going to help us out quite a bit. So sine of t, cosine of t, tangent of t, and the reciprocals, cosecant, secant, and cotangent. So by definition, whenever you have a point on the unit circle, then these are the values. So sine is the y coordinate, which is 8 over 17. Cosine is the x coordinate, negative 15 over 17. Tangent is the quotient of y over x. Y divided by x is is the same thing as multiplying by the reciprocal. So here is y divided by, I'm going to change that to multiplication, and then I'm going to take the reciprocal of the x coordinate, and then you will see that you get cancellation. You get negative 8 over 15. And then, of course, these are the reciprocals of the corresponding trig functions above. And those are the 6 answers. All right, next problem. All right, they tell you it's a point on the unit circle once again. So this is going to be in the 3rd quadrant because it's negative, negative. So that would be somewhere over here. Negative 12. My pencil stopped working, so let me see why that's happening. Okay, there we go. Now it's working again. 12 over 13, comma, negative 5 over 13. All right, so once again, this time they're asking us to find this point. So notice that this is angle T. What we're given is angle T. Now they're asking us to find T plus pi. So T is here. This is the terminal side. We have to add pi to that. Well, if you add pi to that, that's going to just give you, that's going to rotate this point 180 degrees. So now the new point would be directly across. That's 180 degrees. And so the new point would have to be in quadrant 1, which is going to be positive, positive. So the coordinates are the same. The values of the coordinates are the same, except now instead of negative, negative, they're positive, positive. It's positive, positive because we're in the 1st quadrant. So that is the final answer for that one. Let's do the next problem. This time we're subtracting pi instead of adding pi. So if we go back to the same picture, I'm going to erase this. And now we're going to go from the terminal side. We're going to go negative 180. So we're just going to go the clockwise direction. And guess what? We're in the same exact location. So the answer is going to be the same. It's going to be 12 over 13, comma, 5 over 13 once again. All right, and for this last part, negative t, so let's go back to our picture. So if this is positive t, the negative t would be the same amount, but in the opposite direction. So it would actually be over here in quadrant 2. So imagine this is like 180 plus 30 maybe. Maybe it's like 180 or something. I'm sorry, 210, let's say. Then if you went 210 in the negative direction, then it would be right about there. So we're in quadrant 2, which means negative, positive. So the same values except negative, positive. So negative, positive. And that will do it. All right, find the values of the trig functions at t. So we're going to use our unit circle for this to find the 6 trig functions of 5, 6 pi. And of course, also the reciprocals. Oops. Okay, so for this, we refer to our unit circle like we just mentioned. So unit circle for 5, 6. Notice that 5, 6 is right here. Sine is the y coordinate, so that would be 1/2 for sine. Cosine is the x coordinate, which is negative radical 3 over 2. Negative radical 3 over 2. And tangent is the quotient of y over x. So let's do that. Y times the reciprocal of x. So in other words, it's 1/2 divided by negative radical 3 over 2, but I'm multiplying by the reciprocal. And you can cancel out the 2's, so you get negative 1 over radical 3. If you wish to rationalize that, you can. Otherwise, you can just leave it the way it is. Reciprocal, reciprocal, and reciprocal. And those are the 6 solutions. So same thing goes for this one. So let's do exactly the same thing. Sine, cosine, tangent. All right, so let's first locate this angle on the unit circle, negative 2/3 pi. So instead of going positive 2/3 pi, we're going to do the exact same thing but in the clockwise direction, negative 2/3 pi, which would be right here. So negative 2/3 pi is equivalent to 4/3 pi. So we're looking at this coordinate. So the sine is negative radical 3 over 2. Negative radical 3 over 2, it's the y coordinate. All right. Okay, and let's see, cosine is going to be the x coordinate, negative 1/2. Tangent is going to be the quotient, that one divided by that one. So if you divide, you're going to get 1/2 times the reciprocal. You're going to get the 2's to cancel. You're going to get 1 over radical 3. Negative over negative is a positive. Okay, reciprocals. There we go. There we go. And there we go. And those are the solutions. All right, so for this theorem here on repeated function values, it's just telling you that you can add any multiple of 2 pi to the angle and you'll get the same value. Basically, you're looking at a coterminal angle. So 2 pi is the equivalent of 360 degrees. So you're going 1 full revolution for every n. So if n is 2, then that means you're going 2 times around. If n is 3, you're going 3 times around, so on and so on. Same applies for cosine. Then we got formulas for negative functions. So sine is referred to as odd because if you take the sine of a negative angle, that's equivalent to the negative sine of the positive value. Cosine is referred to as even because when you take the cosine of a negative angle, that's equal to the cosine of the positive angle. And tangent, since tangent is sine over cos, and sine would be negative, as you can see, then that means that this has to be negative as well, so this is also odd. And then these are going to be similar to the reciprocal, so odd, even, odd. So we can apply them in these situations. If you have a negative angle and you don't want to find a coterminal, you could find a coterminal by just adding 2 pi. That would give you a positive coterminal, or you can just apply this rule. So in this case, it's odd, so the negative would come out, and then you'd be taking the sine of positive 3/2 pi. Looking at your unit circle, 3/2 pi is here, sine is -1, but you're taking the negative of -1, which is +1. All right, this one is going to be an even function, so it's equal to cosine of positive 225, as you can see up here. All right, so locate 225 on your unit circle, and it is right here. That's not marked, but you can fill it in if you'd like. It's right in the middle of these two angles, and it's going to be cosine is the x-coordinate, negative radical 2 over 2. All right, the next one is odd, so it's going to be negative on the outside of the positive pi over 4. So pi over 4 is equal to, the tangent is y over x, which is going to be 1. So that's going to be 1, but times -1 is -1. So now we're verifying identities. So let's start with the left-hand side again. LHS, left-hand side, is equal to cotangent of -x over cosecant of -x. Well, both of these functions are odd functions. If you look up here, cotangent is odd and cosecant is odd, so we can pull out the negatives. So this is going to be equal to negative cotangent of x over negative cosecant of x. Double negatives cancel. And now we have cotangent, by definition, is cosine of x over sine of x. And cosecant, by definition, is 1 over sine of x. So now we can multiply by the reciprocal, because being two fractions. And when you do that, you'll get cancellation of sine, which tells us that this is equal to cosine of x, which is equal to the right-hand side. And that completes the verification of the identity. All right, the last page on these in this section is the graphs of sine. So we can use our unit circles. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3/2 pi is -1. And lastly, the sine of 2 pi is 0. And so if you connect those points, you have one complete period of the sine wave. If you do the same exact thing to cosine, you're just going to look at the x-coordinates instead of the y-coordinates. So for example, 0, cosine of 0, this is 0 by the way, cosine is 1. The x-coordinate of pi over 2 is 0. The x-coordinate of pi is -1. The x-coordinate of 3/2 pi is 0. And the x-coordinate of 2 pi is 1. So there's your full one complete period of cosine. And so tangent is going to be defined between, for one full period, you're gonna look at the values that are negative pi over 2 and positive pi over 2. That's going to be one complete period. And I'm putting asymptotes here because if you look at these angles, if you do y over x, that's 1 divided by 0, which is undefined. That's why there's an asymptote here. And similarly, there's going to be an asymptote here. Instead of calling it 3/2 pi, though, I'm calling it negative pi over 2 because that's equivalent to to 3/2 pi. So y divided by x is also undefined. So that's why we have two asymptotes there. At 0, we have y over x. That's 0 over 1, which is 0. All right, and then at pi over 4, that would be here, and negative pi over 4. If you look at the unit circle for pi over 4, the tangent is y over x, which is 1. And at negative pi over 4, it's going to be y over x, which is negative 1. So positive 1 for pi over 4, negative 1 for negative pi over 4. And this is what the tangent graph looks like. That's one complete period. And cosecant, so cosecant is going to be, first you have to graph sine. So if you graph the exact same sine graph, you will get, I'm going to do this dashed because that's not actually a graph of cosecant. That's a graph of sine, but we're looking for the graph of cosecant. There's going to be asymptotes at the x-intercepts for the same reason that there's asymptotes for the tangent, because you're dividing by 0 there. And then the cosecant graphs are just going to be these curves that are bounded between those asymptotes, and they touch the very tip of the sine graph. So that would be one complete revolution for cosecant. Similarly, secant, you would graph the cosine function first, which looks like this. And same thing, asymptotes at the x-intercepts. And then you would draw your curves between the asymptotes. So that would be one complete period. And lastly, cotangent, we're going to graph one complete period will be between 0 and pi. And the asymptotes are at 0 and pi because that's where you have undefined. 0 is cotangent is x over y. That's undefined there. And it's also going to be undefined at pi. X over y is undefined. So those are the two asymptotes. Then we're going to look at pi over 2. Pi over 2, x over y is 0. And then we're going to look at 3/2 pi. I'm sorry, not 3/2 pi. Let me see, pi over 4 and 3/4 pi. Pi over 4, 3/4 pi. So pi over 4, that's 1. And then 3/4 pi is negative 1, x over y. So we have 1 over here, negative 1 over here. And so it looks like the tangent curve, but this time it's going in the opposite direction. Instead of dropping left and rising right, it's rising left and dropping right. And that concludes the section.